The substituent effects. You would like, let me tell you from now, you would like your diene to be very reactive. So this is your diene. You want it to be reactive and nucleophilic. And you would like your dienophile to be electrophilic. So you would like this to be electron rich, and you would like this to be electron poor. What is one way of doing this? Well, you can attach what we call an electron donating group, EDG, to the dienes to make it more reactive. So they will donate more electrons, that therefore they will become electron rich, even richer. On the other hand, the dienophiles, you would like them to be electron poor. So what's better than adding a group, a substituent, that draws electrons away from the dienophile? And again, this is what we need to make this reaction faster and actually successful with high yield. So here's an example of an EDG. I did discuss these last semester, but we will discuss them even further in the next chapter, in chapter 17. But they are OR group, ether groups, methyl groups, amine groups. They have lone pairs or an R group. All of these have electrons, and again, they are able to make the diene more electron rich. As far as electron withdrawing groups, there are many of these, so they could be acetyl group, ester group, a nitrile, an NO2 group. All of these, again, are electron withdrawing groups. So they will withdraw electrons away from the diene. So let's give you an example here. If this reaction were to take place and you don't see that much of electron withdrawing or donating groups on each, this reaction obviously would take place, as we said, this way. Let me fix this a little bit. All right, let me just go this way. So the connection is being formed. Do your best on this. Again, you can draw it the other way that I've shown you. I'm not expecting you to draw this perfectly, but this would be the product. It would take 200 degrees Celsius for this, very high temperature and very high pressure. So very, very harsh. These are very, very harsh conditions. So again, this is the other way you can draw the product, and it's totally fine. Whereas if you have this and you have EDGs here, electron donating groups, so this makes the whole thing, the whole diene electron rich. And of course, what you have here is you have an electron withdrawing group. So this makes it electron poor. All you need is a 30 degrees Celsius and, ATM, atmospheric pressure. Very nice conditions. And then you would get the product. Once again, let's show you. So this is the effect of having substituents such as these on the reaction that deals all the reaction. You need electron withdrawing groups on the dienophile and electron donating groups on the electron on the diene. So these are the conditions that we're looking for.